Thank you very much. In this congregation, I'm merely the gardener of this famous flower of Mrs. Stüfling. So I'm trying to do my very best to make it grow, but don't make any mistakes. I'm going to try to sell it to you later on. Hexagon is probably more known to you here at the World Geospatial Forum under the names of Leica Geosystems and Intergraph. So Hexagon is the parent company of these two quite known brands. What I would like to talk about today is how can we make a country more productive using data in a more clever way. And I need to stand somewhere where I can see what I'm showing. That is much better. How can we use this data in a more clever way and actually grow the benefits of using data? We spent generations collecting data, and as a matter of fact, we haven't used it very cleverly. But now data is becoming more accessible, and we can use it in a better way to guide societies forward and so forth. So data, let's look at this picture. In 2003, from the beginning of time up till 2003, we collected 5 exabytes of data. Between 2003 and up till 2011, we had increased that speed. So we created that amount of data every 2 days. And by now, we do it every 10 minutes. Think of the storage and what kind of data we're all collecting. I mean, a lot of things is garbage that we do. We all know it. But there is a lot of information within this data pool. And how can we use this data as a society? I think that's really intriguing. So what I would like to talk about is this industry and how we can use data and maps and fuse it to create a more clever society. And I think what you saw from Dr. Lee is quite extraordinary. China is really on its way to collect data in a comprehensive way and use it. And it's actually probably the most advanced user of geospatial data today. So this industry started with a professional society, and the background was we needed a cadastre in order to set boundaries for property. And we needed good accuracy, but we were slow at gathering this data. And 5-6 years ago, we had new companies popping up, like Google Maps, Bing Maps, and so forth. And they addressed a completely different market. Georeferencing services for the consumer society was a much broader market and a much bigger market. But now we see these two markets being combined. And that's really interesting for the future. So where do I believe that we should go as a corporation? Well, I think we need to fuse data. We need geospatial data, but we need more frequent updating. In certain applications, maybe we can sacrifice accuracy in the data just to get rapid data and rapid data collection. So we call this actionable intelligence. What good is intelligence or action if it's not intelligence? So we need to combine the two. And it really starts with a real-world event. Anything that you're responsible for in your jurisdiction is events, and you want to monitor these events, you want to improve them, or somehow alter the outcome. But then you need to generate a report, you need to plan a response, and then you can execute and improve. And it's a constant flow of information between the real world and the digital world. So we call it dynamic GIS, and it could encompass industries from oil and gas, water management, traffic planning, defense, mining, agriculture, infrastructure, as well as public safety. This is what you as policymakers are responsible for, and you need to improve these tools to make your society a better society to live in. But how do we do it? Well, we believe the cadastre play a basic role, but a key role in creating this new system. It's accurate, It's legal and it's been there. So it can provide a base map for the dynamic GIS system. But a map is not good enough. We can't talk about at these geospatial forums just about mapping. We need to talk about other things in society. So we need to match that with other IT systems. It could be crime statistics, could be crop statistics, or in flooding systems you need to match it with, for example, 100-year flooding levels and so on along rivers. Maybe population statistics. And then you need better sensoring technologies. You need more updated information to overlay on top of your basic map. So you need live video feeds. You might need UAVs or drones, crowdsourcing and everything you hear here today. So this is the basic infrastructure that I think you will design for the future in your respective jurisdictions. And how could it work if we look at a few examples? Well, we are not only active in mapping, we work in the mechanical engineering world. And you can see the same exchange of information between computer-aided design and manufacturing. So there are lots of areas where you can deploy this technology. And we call this smart because we believe that the world needs to get smarter. So what we try to package now is smart infrastructure solutions, smart resources solutions, and smart protection solutions. Because on a government level, this is really what it's about. You need to maintain your infrastructure to become or maintain competitive. You need to utilize your country's resources in the optimal way, whether it's food, land, raw materials, or energy. And then you need to move on. And unfortunately, society, we're faced with a different kind of threat as societies, and that is terrorism. So we need to smarten up when it comes to protection as well. And I can give you a few examples, and that was what I thought I'd do here. Let's take the recent terror attack in Boston. 2 bombs explode at the finish line of Boston Marathon. What happens immediately after those 2 bombs detonated? Well, the general public starts placing phone calls, mobile phone calls. They're even tweeting or sending text messages. What we need to do as a society is we need a georeference system that can georeference even text messages and tweets. And we can do that today with the smart mobile phones. We can actually georeference tweets, text messages, and so on. And we can access these messages in the operational center of the Boston Police. So this is important to actually get the new updated information. Once you've done that, you need to assess that information. You need to set priorities and execute. And as you execute it, it's important to dispatch this information to officers in the field, which means we need to be able to send maps. We need to be able to send text and information to smartphones and tablet computers and so on inside police cars, so that they then in turn can seal off escape routes, seal off airports and so forth. And that's how we can respond as a society. So the map is merely a vehicle, but it needs to be blended with other pieces of IT. And this is what we need to create. If we look at traffic planning, which is costing billions around the globe. If you take a city like São Paulo, 20 million inhabitants, 10 million cars, it's crazy. So it costs a fortune for the local government on São Paulo. And what we need to do there, which we've enabled them to do, is to use GPS systems, video surveillance, and also crowdsourcing information to be able to set priorities and then once again execute. So what the government does is redirecting traffic, adjusting the timing of traffic lights and so forth, and then long-term planning, increase capacity by building away identified bottlenecks. Another example from society could be electric utilities. Electricity is vital to a society, a modern society. And the two problems for electric utilities is power outages and power thieves. Once again, via modern technology and sensors, you can geo-reference power outages before they even happen or have impacted your consumers. You can geo-reference power thieves, identify them and eliminate them. So once again, you need a map, but you need it in combination with real-time information. And then you can once again execute by send preemptive maintenance into those areas or reactive maintenance to fix an outage to minimize the cost of power outages. This is a completely different example, but I just want to show you the infrastructure of information. This is shipbuilding, so it's in our other division, which has nothing to do with geospatial. But once again, we combine sensoring technologies to build large ships and make it precise, reducing scrap and reducing manufacturing time, i.e. saving resources for society. But it's the same flow of information once again between software systems displaying the real world, sensors measuring the real world. Port optimization, that's my final example, and here I want to show you what kind of information you can build into a comprehensive dynamic GIS system. What is a port really about? You have a fantastic port nearby here, Port of Rotterdam, which is one of the largest ports in the world. Well, it's really about optimizing water and land resources. And it's a big logistics hub to move goods to and from ships. But how do we get about it as GIS creators? Well, we start with aerial photography. We want to document the port. So we fly over the port with aerial cameras or LiDARs just to document it and get a reference. And eventually that leads to a GIS. But is that really what the port needs? Well, very seldom the port change its infrastructure above the water surface. So what the port really needs is a simplified reference like this. But it needs a detailed, real-time map of what's going on underneath the surface, because they need to constantly dredge the port so they keep the draft. What it also needs is to identify ships and geo-reference ships in real time as they approach the port. They need to know, for example, what's the name of the vessel, what does it carry? Is it chemicals? Is it dangerous, hazardous materials? What's the length of the ship? What's the draft? Does it need tugboat assistance? So in this case, we know Amanda May is out there. We can geo-reference Amanda May as soon as she approaches the harbor. We need to know, yes, she needs assistance from buoy 5. Where is buoy 5 and where is that line when it needs assistance? I need the position of the tugboat. And I know the draft is 15 meters, so I need to know where can I moor this vessel? Where is the draft deep enough right now with no dredging and so on? And I find 3 locations in my port. Now, this is a much more dynamic way of planning your mapping needs. And this is what we need to build into our resources for the future. We need to be able to plan in greater detail geo-referenced objects. So the more we know, the more we can model, build and scale to the point where we directly and deliberately guide. And we believe this is the future for this industry. Thank you very much.